Okay, thank you. I'm Heather Dahl, and I'm CEO of Indicio. I have been in the space of decentralized or self-sovereign identity for just over a decade now, having worked on these projects for quite a while. And Indicio, what we do is we provide the components for verifiable credentials and decentralized identity to create trusted digital ecosystems for organizations, companies, entities around the world who are looking to exchange verified data. And so today, what I want to talk with you about is based on the experience that I've had specifically over the last 2.5 years, because I have been, for the first time, had the opportunity to really roll up my sleeves and work with organizations and industries and consortiums in deploying decentralized self-sovereign identity using decentralized ledgers. And I have learned more in the past 2.5 years than I did all the years prior, because there's one thing to talk about the theory and the thought behind decentralized identity, and actually being on the ground, deploying these solutions, working with the general public on how do they use them, how do they share and exchange verified data for a myriad of use cases. So what I want to talk to you about is how decentralized identity is actually more than verifying the identity of an individual. That is key to how we look at decentralized identity. The identity is everything, because at its root, this technology is about determining the trustworthiness of any given data point by virtue of its authenticity and its integrity. So decentralized identity can be put to work today, and I think that's really important. This is technology that is being deployed and being used at production and for commercial solutions now. And we have the entire technical stack and capability to actually do that. And we're deploying these verifiable credentials in trusted digital ecosystems. These are not necessarily proprietary platforms. These are ecosystems of organizations, competitors who are looking to exchange verified data. And the businesses, the public sector, and even entire industries now have the ability to positively identify and repeatedly verify any given data point using the inherent trust and the immutability of a blockchain ledger. The business value of verifying data quickly and efficiently is really almost limitless. And only if we actually use the technology and we start deploying what we have available to us now in the open source systems, which I know Hart is going to talk about here shortly, when we can actually go out and use these, that's when you realize the value. And what I'm here to say is that what we have in the open source community, in Hyperledger and the Decentralized Identity Foundation, and also some of the work that Hart is doing with the Open Wallet Foundation, it works. And it works today. It works at this very moment. And we can deploy it now. And in fact, the reason why I can't be with you today is I am actually working on site with customers who are deploying this with customers in the market. And so, I come to you really excited about what I see in the world. The technology exists in really a blank slate. So you can use the components in the Hyperledger repositories, and they can be used now to remove any wasteful processes, to remove fraud, to remove duplication of data, to remove the need for direct integrations, and actually to remove the dependence on costly platforms, specifically around federated identity platforms. And I know that's a concern in the public sector, is the amount of money, especially in this world of budget cuts on the public side, and how do they create efficiencies but reduce their spend. The fact is that this technology, it can go anywhere, it can do anything, it can identify anything and everything. It does not have to just identify humans in what we think of, maybe I call it a driver's license identity. So the question is, what is decentralized identity anyway? Let's look at the table for success by laying out some definitions here. Decentralization is about changing the control of things. So what is the technical goal of decentralization? It's to always live in the pre-digital world, and it gives autonomy to each entity participating in the exchange of information. You know, in this world of digital technology middlemen, you can go back to actually being your own controller. And you can go back to a world of direct relationships, whether that is with a person, whether it's with an entity, whether it's with a government agency. And you can do this by being a credential issuer, a holder, or a verifier. And in fact, organizations can be all three at once. And most organizations begin their development in decentralized identity by playing the role of issuer, holder, and verifier within their own organization. And why is that? Well, it's to protect privacy and to achieve consent for all parties. At its essence, this is about transparency. It's about transparency of how we share and verify data. But let's look at the facts here. The business of data is not usually in alignment with the business of privacy. And until regulatory change really compels compliance, I think that is the point we will see these systems become ubiquitous. But until then, we see businesses moving forward with these systems to reduce friction and remove fraud. We also see it is especially important when privacy and control are the philosophical objectives. And when I say control, it should be control of the holder is the philosophical objective. Oftentimes, we get really caught up, especially in this industry of decentralized and self-sovereign identity. We get really caught in the dogma of principles. And therefore, that philosophical debate oftentimes prohibits our ability to move forward because of the continual debate. But what I'm here to talk about is it's possible that you oftentimes miss the business value of the technology and the motivation that will drive adoption when the debate continues to be about philosophy rather than moving philosophy to action. So a focus on real world problem solving at this phase in this technology maturity is required for the success of decentralized identity. You know, the values of decentralized identity are really the starting point to build a pragmatic business value first, and then you move forward. That's not to say that we need to disregard our core principles by any means. But the fact is, it's beyond time for this space and this technology to clearly articulate the value of this technology by demonstrating it through actual deployment. What I'm saying here is that we've reached an inflection point, and we are at a moment where business value can actually drive adoption. When it's clearly articulated and solved for, it can promote those philosophical values that we all agree upon in the decentralized identity community. And it's not the other way around now. The business value is driving the philosophical adoption. What's needed to accomplish this, though, is how do you take a simple, repeatable set of technology to demonstrate that business value when it's deployed? So let's talk for a minute about identity. Okay, I'm going to talk about the lowercase and the uppercase I. And what do we mean by identity? Largely to date, we have focused on positively identifying people. as the risky participants in any given exchange of information. And it's a really useful case. It's a case, the personal identity is a case that people understand because we can feel it, because we understand and feel that emotional ownership over our data. But largely to date, we miss a lot of the deployments which really make a difference, and that's the exchange of information. And that's a very useful case. It's not necessarily about the exchange of human identity, but it can also be the exchange of entity information. And I have to plug my laptop in here, but what I'm talking about is to move beyond the biographic information that we often think about identity. And when we think about deployments of this, we think about moving to the other types of identity. And one of the earliest use cases here is, how do you trust data points between organizations that may not necessarily be about human identity? And where we see more than half of the deployments using decentralized identity or self-sovereign identity today is actually about other data points that do not include necessarily your traditional, what I call lowercase identity, but I'll call it here the everything identity. What we're really looking at in these deployments is, how do you link trusted data points and build trust on all those points? And so what you can see here is you have, in this case, for climate accounting, this is one area that we see quick adoption of self-sovereign identity. How do you have the ability to account for emission monitoring device data that is being sent to participants, and do so in a way that eliminates, for instance, double spend accounting, that you understand that who the device comes from, that you believe and trust in the device. These are the type of use cases which are actually driving identity. And therefore, we really talk about what we're doing here is we are exchanging verified data points in a way that can come together and create the context of identity. But when we focus on identity as a human, or just what is contained on your passport or driver's license, it really shorts our ability to go out and drive the business value. And so one of the things I challenge in my conversation today, and as you think about decentralized identity, is that everything is identity. And what we are talking about is, how do we exchange verified data points without direct integration? In this case, you have data that's being generated by a device. You have the ability to show that it's been legitimately written by the technology, and it's supported by what's now created by its own identity. And it has the potential here to be further supported by biographic and human identity credentials as well. That is the part where the human comes in. A thing, an organization, or an entity, I always talk about the data has a throat to choke behind it. So who is the responsible party behind that identity, and how do you bind them? So first, when we look at these deployments, we look at first, how do you exchange and verify endpoints? And then second, how do you verify who that endpoint, who that data rolls up to, and a human who has made that decision to either exchange or verify or make a business decision after receiving that piece of data. The fact is, what you see here today in this particular use case is actually in deployment. And in this case, they've been able to link all these pieces of information, bring it together into identity. It's at work. It's using the technologies in Hyperledger, and it's using technologies in the Decentralized Identity Foundation. And suffice to say that with this typical definition of identity, you see that these are small subsets of data points that can constitute a wider definition of identity, and then all can be equally verifiable and then immediately valuable. So let's move on. Relationships also generate identity data, and relationships provide a lot of data beyond just the human name, birth date, where you live. And so we as humans create identity, data, which also creates additional value. And so let me circle back to the individual here for a minute, because that's a lot of what we're talking about. It's a lot of what we see in use cases that are discussing. And let's focus on the understanding that any event or relationship an individual experiences can also constitute their identity, and it can have value to prove anything to another party. So an employment relationship, a financial transaction, a contractual relationship, when any three things can be codified as a data point and are attested to by someone other than the sole individual, they become trustworthy and thus potentially valuable to others who receive the data. And that is a very important part, is how can you provide verification of a self-attested piece of data? And that's where these ecosystems come into play. So this is what, let's take a look at this. This is what I call, and we call it Indicio, everything identity. What I mean by this is that any given data point can be used as a proof of demographic, biographic, or institutional existence or asset, assuming that you have the authenticity and integrity of the data point that's been proven, and the source of the data point's origin can be trusted. Let's frame it in the language of regulators, that everything greater identity is any given data point that can be associated with any given data subject. In other words, really identity is everything. But what does any given data point make trustworthy in a data exchange? First, a data point, when we look at it, we look at authenticity. Can I positively identify that the data source that it claims to come from really came from that data source? And second, how do you trust data? It's from its integrity. Can I positively know that this data point has arrived to me without having been altered en route? Once the answer to these first two questions is yes, now I can decide a third thing. Is it useful? And usefulness really exists if I inherently trust the original source of the data, the issuer here. This can be by virtue of a contractual relationship that I already have with the data source. This can also be in the sense of it's a known entity that you have inherent trust as whatever the business decision is. Once you have that trust in the issuer, it's often because you understand the processes and work that went into actually issuing that particular data point. Or it's in using your human trust in the institution or the traditional cultural value of the business or entity, and that it's generally understood from a regulatory environment. In that case, many of us understand what it took to get a passport or driver's license issued, and therefore we trust it even though we don't have a direct contract with the Department of Motor Vehicles or a home office that may be issuing that passport. And the third part, and the most important part here, is once the identity has been garnered, the governance mechanism of executing its trust relationship is really important. But I'm going to get to the governance on that later when we talk about autonomy. So let's say all three conditions have been met and we move forward and we make our decision. But then often the question I get is, well, what if one of the conditions was not met? How do I trust the issuer? And oftentimes it's seen as, well, if you don't trust the issuer, well, then why even bother? But I'm here to say, actually, having an untrusted issuer and knowing that that is an untrusted issuer is just as important as knowing as to whether you do trust an issuer. And that's because it's valuable to know what you can't trust and to be able to discard that data. And so it can be just as important to know who you can't trust as who you do trust. In fact, I would argue that a data point, one which can be technically proven to be authentic and intact, but comes from a source that you don't trust in the context of the data is more valuable than coming from a trusted source. And that's because it can create efficiency by making a smart decision on what data to discard, because trustworthy data drives efficiencies and it removes the manual and redundant processes. What untrustworthy data does is allows you to reduce your risk. So with a verifiable credential, you can do both those things. You can decide who you trust and who you don't trust. And oftentimes it removes that argument of, well, if I don't trust it, then I don't need to be engaged with this technology because I don't know who to trust. And we're here to say, no, by not knowing who you don't trust actually reduces your risk. And then we see quite a few organizations using this because it helps them quickly remove the data or the credentials that they don't trust the information from, so they can focus on the information that they do trust instead. The real truth is that the vast majority of the data that is exchanged is in fact trustworthy in a lot of these systems, and the incidence of fraud and error is actually really low. And we are seeing that through deployments and implementations that have been going on over the past 2 years. But the problem is with errors and fraud with systems that don't use decentralized identity is that it's costing organizations worldwide billions of dollars and trillions if you try to count all the work that goes into trying to combat all that fraud and error. And so for certain types of data, especially highly sensitive or highly regulated environments, for instance, crossing borders between countries, even a tiny bit of untrustworthy data is entering the system does carry an enormous amount of risk. And so what these systems have been able to do is reduce that risk because of the tamper resistance form of the credentials and the ability to immediately detect whether there has been tampering behind that credentials. So I don't think a lot of the information here is maybe relatively new for some of you on this call, and that's okay. But what I want to do is set the table to talk about what comes next here. And that's because with a component-based trusted digital ecosystem, we have seen that this works. For instance, the foundations of business value. We have seen this deploy using the travel system for what we call DTCs, or digital travel credentials. In this case, what you have is, for the digital travel component, is you have a trusted digital ecosystem where you have organizations that are issuing a passport or DTC based off of the chip that is in the passport and binding that with a liveness or biometrics check at the time. So an individual or a traveler scans their passport and OCRs the information on the actual page. They also then are able to pull the information out of the chip in the passport. And then the chip has the biometrics information, which then they can use the liveness checks to make sure that the person who's holding the device matches the biometrics in the chip. We see the holder is the individual or the traveler who then has basically the equivalent of a digital passport, then is then provided to arriving country for pre-clearance before they even leave for the airport. So when they're still at home. And so this is this is an example where CETA, who provides travel networks and solutions to governments and airlines around the world, have been actively deploying and working in this business value. In the sense of, yes, you are, in this case, sharing a human sense of identity. But the foundation, the trusted digital ecosystem that they have built here for this business value, can then be moved to any type of information that is in the aviation system, from everything from sensors to parts to providing more focused and personalized shopping experiences. So what is it that's inherently different from what we're doing today with the centralized databases? And what trusted digital ecosystems do is allows you in one way to return back to the mail system, where you put your mail in the box and it arrived, and if the letter arrived and it was opened or the seal was broken, you had to send someone got in there and may have been privy to what you sent. But the mail service didn't open the letter. The mail service didn't get in there and read what you were providing, pull out any data, put it into databases. And that's what a trusted digital ecosystem is doing. It is going back to the sense of it allows that peer-to-peer encrypted connection, and it creates a direct relationship between the holder and the verifier, or the holder and the issuer. And that is becoming more important for organizations when they're trying to understand that the data that they get is not coming from a bot, that it has not been altered en route. When you think about oftentimes what a receiving organization gets, it's not the authentic authoritative data. They're often receiving replicas of data, or data that has been analyzed and sent to them that may not be the original data they want. And for high value decision makings around, for instance, border crossings or medical decisions, they want to know the authoritative data that was issued to you directly from the origin. And that is the key to what we're delivering here today. And they can do that without any direct integrations. And so a trusted digital ecosystem provides the same reason why you would mail a letter or why you would use an email, but it creates a more efficient way to do that. So the fact is, for businesses and a lot of the organizations, is that efficiency is saving money. It is saving time. And in the economic climate that we have today, there are decisions being made in companies where they don't want to spend as much money as they have on centralized or federated identity systems. They have gotten to a point with some of their security spends that they cannot continue to add more and more layers of security. In fact, some of them are looking at how they have to reduce their security budgets, but they're trying to make those decisions where they're not losing the trust that they have in the data. And that is where we see trusted digital ecosystems coming in quickly to help support organizations who have to make those tough choices. Because what they see in a trusted digital ecosystem is that they can get any type of verified data point, and they can do so efficiently with, in fact, more trust than they had with the systems that were costing them a significant amount of money. And so that is where we see the quickest adoption. And once organizations have realized when it comes to decentralized identity, it's more than human identity, that's where we see the rapid development. You know, this is really a look here at the digital travel credential project that I talked about earlier. And this is one of the areas that I think you can actually spend some time and read about. CETA has published a lot of information and videos as well about the system. The digital travel credential, or the DTC, is an ICAO specification. And so what's very interesting about this is because of the ICAO specification, it allows the entire travel aviation industry to become an ecosystem of itself. And the verifiable credential is helping to bring the DTC data and the specification to life and allow organizations to all participate without having to move to one proprietary system in order to participate. Because when you have these, what I call dynamic growing ecosystems that could involve hundreds of participants, it's very important to focus on this open source, open standards approach to creating these ecosystems. So let's talk about governance here. This has been a topic. How do you trust? Who do you trust? When do you trust? Who makes the decision about what you trust? How do you trust that they made the right trusted decision, right? You can see where I'm going here. And this has been a topic for as long as I've been in this. When 2 years ago, when you had organizations, for instance, the system with CETA, where they're bringing together governments and airlines, understanding the governance was very important, but in the sense of it had to be able to scale and allow each participant to make their own decision and do so at the pace that that organization needed. And the philosophy and the thought up to that point was what we'll call a trust registry, that there was one registry that people would write their information, it would function, and it would provide that trust decision. And what we found in those early days was that it was not providing the trust decision at the speed that was needed to scale. In addition to that, the registry did not meet the changes at the speed the governments needed changes to be made and who they trusted. When some of the earliest cases here were on COVID restrictions, and as you can remember, the science was changing sometime by the day and the hour, and so governments were changing their requirements for border crossing sometimes a few times a day, and so they needed the ability to quickly do that regardless of a registry or the other participants. And so what we see here in creating governance is, how do you have agreed upon value about any kind of data point, but make it so an individual or an entity can control their own decision about what they trust. And that is where ecosystem governance comes from, that you have decentralized ecosystem governance, and each entity can have its own machine readable governance file to decide what piece of data they trust and when they trust it. And so that is where you've seen the decentralization of governance go on. And the importance about the decentralization of governance is actually what is allowing organizations to move forward and deploy these solutions to market, is because they feel confident that they have the self-sovereignty to make their own decisions, regardless of what a third-party trust registry or a rules engine would be able to keep up or decide on their behalf. Organizations were at the point where they did not want to abdicate their decision-making to a trust registry or rules engine that was operated by another entity. And so why the success of some of these earliest COVID solutions that appeared, and why, for instance, what CETA is doing, although it started with the COVID solutions, most of these COVID health solutions that came out rapid fire in 2020 and 2021, they've stagnated. And when you look at why did so many of those COVID health solutions around verifiable credentials stagnate, it's because the foundation wasn't there, and the governance was really looking at how do you create these registries. In the case of CETA, where they focused on was how do you create an open source, interoperable, component-based ecosystem, and you decentralize the governance on top of it. And so when this time of COVID and health restrictions was lifted, they could use that same system to evolve it for other use cases. In this case, the digital travel credential that they have developed and are working with the government of Aruba on, and airlines as well, was actually the original foundation that was used for sharing COVID health information. And in fact, the switch over to a DTC was fairly minimal, because they're actually using the same ecosystem. They've just changed out the credential and how it was used, and they've adjusted the governance to do that. And I think that's really interesting, because what they realized was it was about the data they were exchanging, and they can continue to use the same ecosystem for that data. So let's talk about, how do you reclaim the direct relationships using a component-based credential exchange? You know, in this case, when you look at, the government used to issue the citizen the credential with the information, and then you would present it and the government would verify it. In this case, you've switched it around where the issuer provides it to the holder, and the verifier could be anything for the ecosystem. Some of the earliest cases, and those that have moved the quickest in sharing verifiable data, as I've talked about, they're oftentimes the issuer and the holder and the verifier. These use cases are those that there is immense internal friction. When you look at financial institutions, and these are some of the earliest cases for what I call closed digital ecosystems, is around KYC. A new customer will open an account with that financial institution and provide KYC. To do that KYC and determining the customer costs the financial institution money.
Excuse me.
Usually, organizations
No?
provide that. Oh, yeah.
Excuse me.
Yeah.
So it's time to close your talk. And could
Oh,
you
yeah.
could you
Sure, I will wrap this up. Usually organizations have to spend time and money re-verifying KYC. And what these ecosystems do is they allow the same organization to provide that same information across the organization, regardless of where the data sits and who controls it in the organization. So my last slide here is actually, there is tremendous value when you think about identity is everything. And I think what you're going to hear are all the different ways in which you can take any type of data and package that into a verifiable credential, and therefore drive your use cases to lead and reduce friction and to reduce fraud and drive business value. And the technology is available for you to go out and do it now. So I turn it back over and thank you.
Okay, cool. Yeah, so hi everyone, I'm Shrey. I'm an applied scientist at Microsoft Research. This is joint work with Glenn Weil that I'll be presenting today. Part of this talk will be centered around soulbound tokens, but we'll also be painting the bigger picture of some of the research that our lab is going to be focusing on moving forward. And the title of that work is called Plural Publics. And so to better understand what it is that Microsoft Research has done in the past in the Web3 ecosystem, just sort of highlighted some of the key contributions here so far. And this does not fully exhaust them, including much of the work we've been doing with zero knowledge proofs, optimizing zero knowledge proofs, and the more technical foundations we've been doing in the Ethereum ecosystem in particular. But here are some of them, namely differential privacy, proof of work from Cynthia Dwork, quadratic voting, and quadratic funding from Glenn Weil, as well as a lot of the social science work that has been outlined by many of the social science researchers on our teams. And in this work, we started to better understand a lot of the social problems that people have been facing when it comes to communication. And in particular, it comes to these key properties that existing digital social systems have been unable to achieve. And we've distilled these key properties into the following. One of which is called common knowledge. So everyone knows that everyone knows that everyone knows that something is true. This is the most rich form of knowledge that one can achieve when it comes to communicating, and it is most easily attained in the physical setting. So if I'm in a room with someone else that's with a door closed in it, and I'm looking at someone and we're communicating and they're listening to me, then I know that they know what I'm saying, and I also know that they know that I know what I'm saying. And you get these very rich forms of knowledge that can only be attained in the physical world today. You also want to have these other properties in a digital communication system. You want to have unforgeability. So the way you can think about unforgeability is that if I go to a coffee shop with someone and we have a conversation, there's no way, unless someone records me speaking and can prove that that recording was in fact me, that I in fact said the claims that I've claimed to be said by this third party. And finally, you get these two other properties that are currently hard to achieve in digital systems, which is off the record or deniability, meaning that someone cannot later prove that the message came from the sender, and finally consistency, such that you can do all of these things across multiple people. And so when we think about social platforms today, whether they be social media platforms or other forms of communication through SMS or XMPP, which is what WhatsApp and Telegram is built on, or email on SMTP, they don't satisfy all of these properties in a way that we may want to communicate in. And so in a communication system that satisfies all of these properties, we're coining that to be what's called one of many plural publics. And it's the most efficient form of communication as it's indistinguishable from physical. To better understand common knowledge, again, it's just like if you're in a room and someone says something, you can imagine if I was in stage in Vancouver right now and I was saying, everyone in that room would have common knowledge around what I was saying. But right now, because we're communicating virtually, we don't achieve it. We achieve weaker forms of common knowledge, which are often referred to as common P belief. A lot of the work that we've seen right now around identity and the communication protocols we're looking at have been bucketed in this area of applied cryptography. And so in particular, in the Ethereum ecosystem, we've seen the influence that zero knowledge snarks have had on various different areas of the ecosystem, including proof of solvency on centralized exchanges. And that's been something that's been done since 2014 with exchanges like Kraken, but only more recently with more large exchanges like Coinbase or Binance. We're also seeing the influence that zero-knowledge snarks are having on ZK rollups and the ways that we can have scalability on these different settlement layers. And finally, what I will be focusing on today is how zero-knowledge snarks can influence the identity stack, in particular, being able to create what are known as zero-knowledge soulbound tokens. And all in all, what we start to get to through this work being done in the ecosystem of applied cryptography and blockchains is what many in the research communities in the Ethereum ecosystem call programmatic cryptography, where the problems that individuals have to solve to enable a lot of the different cryptographic constructions becomes more of a developer problem, and then it does become a mathematical problem. And we're starting to see that with various different types of signature schemes on Ethereum today. So in particular, the signature scheme that we've been working on creating and making possible for the Ethereum users to use is called designated verifier proofs. And a designated verifier proof works as follows. Instead of proving X, Alice will prove the statement either X is true or I am Bob. And essentially, of the properties I discussed earlier, designated verifier proofs allow one to achieve unforgeability, off-the-record deniability, and finally, consistency if you issue this proof to multiple people. And so why might this proof be useful? Well, in today's communication system, let's say I send a message to someone digitally. There is nothing that I can do to prevent that person from sharing information. But what I could do is I could prevent whoever they share that information with from believing them. And so the point of the designated verifier proofs is to reduce the probability of belief that a third party has when information was shared with them that is not consented upon the group that was communicating with it originally. And so some examples of where this could be useful is in voting context. So a voting center wants the voter, Bob, who is a designated verifier, to be convinced that the vote was counted, but Charlie, a third party, should not be able to know how Bob voted with high persuasion guarantees. And this is to prevent coercion resistance as well as collusion when we think about voting. Finally, context collapse prevention. When we have a way of ensuring that the communication that is spoken between a set of agents is only persuasive to that set of agents, then we know that any third party will not believe this information with high guarantees, and therefore we're able to create boundaries on digital communication systems. And so where we're seeing, and sorry, very, very briefly, we did release this in open source and is accessible by the community, and it was collaborated on not just with Microsoft researchers, but the community as well. And where, in order to get to be using designated verifier signatures and being able to build these forms of plural publics that I commented on earlier, we also need to be thinking about more concretely at the identity layer, what does each individual look like? And so something I was recently talking about was set membership. And so today, when it comes to, we think about permissioning or accessing controls or permissions, we are very limited in the actions that we can take in the social platforms we have today. As an example, if I want to tweet something, I have two options. I can either tweet it to everyone or I can tweet it to my Twitter circle. But as we identified earlier, one of the key problems and properties that we're trying to achieve in a digital communication system is avoiding context collapse. And so what we're trying to work towards is this idea of, I could say, hey, I want to tweet to everyone who was at the conference that I was speaking at today, because everyone here has the context to understand what it was that we experienced together, whether that was someone that was at the coffee break in the conference room and they wanted to tweet out, hey, maybe everyone in that coffee room was issued a soulbound token because they got the coffee from the specific machine. Then we start to be able to have very targeted groups that we can start to share the information with in public social systems and do so in a way that preserves context. And the ways that we move towards these types of systems is through a lot of the set membership work that's being done on-chain and off-chain today, that relies on being able to verify various different types of cryptographic signatures. On Ethereum, that might be ECDSA signatures, on GitHub, that might be RSA signatures, and being able to then generate these proofs in a way that the public can verify, such that they can be part of these different subgroups. And we've been looking, so yeah, I guess the benefits that this has is a lot of people a lot of people today talk about how we're aiming to reach pseudonymity when it comes to communication, because pseudonymity is the way in which we can reveal a lot of the preferred preferences. But the reason why we may also be interested in set membership is not just for pseudonymity, but also to preserve context when it comes to communicating. And so to make this possible, we, again, with the similar group of researchers, we released what are called zero-knowledge soulbound tokens. And so what these zero-knowledge soulbound tokens allow you to do is they're essentially an NFT that lives on chain, whose metadata contains a proof from a zero-knowledge snark that is able to be publicly verified by anyone on chain, but the data and the inputs to that proof live off chain and can be only accessed by those who want to share that information. So you still preserve privacy, but you get public verifiability that an action took place by keeping the proof on chain. And this is a repository that's open source and being used by many different Web3 communities today. In addition to that, we were looking at a lot of the different trade-offs earlier this year in the summer when it came to using various different types of primitives for the types of actions one may want to take in the Ethereum or broader context of decentralized governance, as well as decentralized decision-making more broadly. We looked at the trade-offs between decentralized identifiers, and we looked at the trade-offs between NFTs and how and what needs to be done in each of these different technical primitives, as none of them are sufficient for some of the actions that we want to take place. And we outline that clearly in this paper. So one of the questions I often get is, why is it useful to build on a blockchain? And what is the purpose of building on a blockchain? And I've my answer does update quite often, but I think there's two key reasons. One of which is you get this programmatic cryptography benefits. And this language has become well adopted in the zero-knowledge research community in Ethereum. And what I mean by that is, previously, if you had a cryptography paper and you wanted to find a way to make that signature scheme possible in the real world, you had to create a net new construction of this mathematical framework of how people could get keys, how those key generation could then lead to communicating, and have the network effects to make it sufficiently secure and decentralized, when you already have a lot of those properties existing on widely adopted blockchains like Ethereum. And so long as you can make a lot of the tools that we want to use in the cryptographic schemes possible, anyone can connect to it. And so when it comes to having the economic benefits of having programmatic money and smart contracts, those are far, to me at least, secondary to the benefits of having the interoperability and being able to kind of keep layering on these various different types of signature schemes, which may have started off with some of the foundational schemes to build the Ethereum blockchain itself, but have later been layered on to do various different types of cryptography, such as zero-knowledge proofs, group signatures, designated verifier signatures, that have all been able to realize the benefits that these initial academic papers have been able to translate to a wide group of customers. Secondly is the Web3 community, as compared to other communities, it has a very high interest in experimenting with these primitives. When we think about the interest in looking at zero-knowledge proofs in particular, of the many communities that have looked at this over the past 2 decades, the Ethereum community has one that has really made the tooling accessible and usable by the everyday developer. And so it's quite promising to see how we could continue to further that work and the work that we're doing with different types of signature schemes for more socially focused outcomes. And additionally, there's some actual technical benefits of this work. And so there's some work being done on how the blockchain as a protocol is one of the most efficient forms of knowledge distribution that gets us to this form of common knowledge that I talked about earlier, because of the way that data is appended to the network. And that when you append data to a network within a very local region, everyone knows that everyone knows that everyone knows something is true with sufficiently high guarantees. And so there is some actual technical benefits of doing so on a blockchain, but doesn't need to have these economic benefits associated with it. Could also be done in any distributed ledger technology that satisfies the properties outlined in this paper. And so this kind of highlights the work that we've been doing at Microsoft right now around plural publics. It gives a flavor for both the identity stack as well as the communication layers that we've been working on. And now I wanted to open it up to questions for a couple minutes.
Thank you very much. We have, okay. So we have 7 minutes for the Q&A. Okay.
Hi, Shrey. Love your work. Super excited to obviously see all that new data and information. I'd be keen to hear your perspective on how long do you think it'll take till the ecosystem has caught up to like proto SBTs, then potentially SBTs themselves, and then like zero knowledge SBTs. Have you considered how long it's going to take and what features may be required?
Yeah, so I guess the way I'd go about answering how long it'll take is like, what are the constraints today to getting this adoption at scale? And I think to me, it comes down to cost and scalability. And cost is centered in two key axes. So one is like to process a transaction on Ethereum costs money. And secondly, to do zero knowledge proofs, you need to generate these proofs in some way. And on a local machine or in a browser, these can be computationally expensive. And so what's becoming of high interest is doing proof generation in the cloud. And if we do this proof generation in cloud, again, this can add expense and can become quite limiting to teams who don't have the funding to be able to do this at scale, especially if we're talking about doing ZKPs on very minute or small types of authorizations, or what are called like micro authorizations. I think today, most of the internet is built on these micro authorizations, whether it's with OAuth or JSON web tokens, JWT tokens. And it's these micro authorizations that are done at scale in a cheap and scalable way that have allowed us to have a lot of the permissioning and membership that I talked about earlier really well. And so I think until we figure out those two things, I can't see it being widely adopted. However, I think the work being done with scalability on rollups, as well as with the work being done in AWS and Azure and other cloud systems, is promising to see that this is not far away. I'm hesitant to give a time though.
A million other questions, but I'll pass it on.
I think this is a follow-up question. So you mentioned about the scalability in terms of the computation cost. I wonder if the shared communication or the query for the data or token on the blockchain can be a bottleneck. For a small scale, I think the current Ethereum can provide any data for free. But if you scale this up to the authentication requests at the airport or authentication requests for IoT devices, then I don't think the current network can support that level of throughput. So I wonder what will be the scenario in the future if we want to have SBT in the market. Should we rely on layer 2 extension, or should we just rely on some other technique?
Yeah, it's a great question that I think lies in similar answers. I think one of the questions that's been of high debate is like, what should live on chain and what should live off chain, and then who can index what data. And I think it's an interesting point, because it's like there's some things that do we need to have this globally readable on a network that has these security parameters through the decentralization it achieves, or can certain data live off chain? And if so, how do we determine that if it's living off chain, that it's living sufficiently decentralized off chain? And what does that look like in practice, whether it's like with IPFS or other types of off-chain solutions? And so I think the way that I've thought about it, at least in very local context, whether it's like I'm deciding to use this soulbound tokens for a set of transactions that I'm taking place in a supply chain context, for example, I may only have 6 or 7 partners in the supply chain lifecycle. And so it probably doesn't need to live on a layer 1 for sure. It could definitely live on a layer 2 or a layer 3. And if so, already reducing the cost of making this possible. And furthermore, you could even potentially have a way of doing this trusted setup off-chain in a way that has these same properties that I talked about earlier. Like, so long as you have a distributed ledger technology that has T consistency, which means that everyone's ledger behind a certain date is all the same. And 2 is that you can add data to this ledger within a sufficiently short amount of time, then you're able to get common knowledge, and you could easily build these systems with unforgeability, deniability, and consistency as well. So there is like questions that remain of like, what should we put on chain and off chain? And I think in identity, it's particularly important.
Okay, thank you. We have 1 minute, 2 minutes to have another question.
Hello. Have you like explored other blockchains other than Ethereum while implementing the ZK proofs, like Mina protocol or Are you exploring other blockchains as well?
Yeah, we're not fixed on one blockchain whatsoever. It's more so what tooling exists today, how easy is it to use, and what's being adopted the most. Mina protocol is one of the, ZK focused protocols. I know there's a lot of talk being done right now to have a new protocol that just uses ZK as the foundational layer of how it's built. And so I think at the end of the day, we're not optimizing or trying to be in any type of blockchain camp, but we're trying to focus on, of the tools that exist today, what's being adopted at scale, and then how could our customers and the people that we work with benefit from the most. And so a lot of that depends on the size of the ecosystem adopting it.
Okay, thank you.
The last question. Okay, for last question.
For the person who didn't get their question, and I'm also very accessible on Twitter, Shrey Jain, so you can DM me.
Oh yeah, my question is actually about lattice-based cryptography and whether you've explored the newest standards established by like NIST in terms of like anomaly, in terms of the anomaly detection on on-chain monitoring systems. Yeah.
I personally have not, but I'm sure there's someone on our team who has. I think if you also look curious to see what our team is doing, it spans many different spaces. To our knowledge, I think it might be the largest research team now in the Web3 ecosystem at Decentralized Social Technology Collaboratory. And I'm sure there probably is someone there, and I can look into that.
Well, I'll go ahead and get started then. And thank you for the nice introduction. My name is Hart Montgomery. I work for the Linux Foundation. And today I'm going to be talking about the Open Wallet Foundation. So to start, I want to bring in some background from traditional digital identity, because it's essential to understand this to see why the Open Wallet Foundation is necessary and what people are going to use it for. So in the beginning, there was sort of centralized identity, and this is, obviously, certificate chains and things that are people are very familiar with. And eventually, federated identity became popular. More recently, as Heather talked about, decentralized identity is becoming extremely popular. And I know Heather talked about the diff, but there are a number of other players in this as well. So if we want to think about digital identity, right, all credentials are based on what a lot of people call the trust triangle. There's a credential holder, there's a credential issuer, and there's a credential verifier, right? And all of the issuer, writes some information to some kind of verifiable data registry, which in many cases is a blockchain, creates some credential and sends it to the holder. And then the holder uses this credential to issue a proof to the verifier. And the verifier can check on the blockchain that sort of the information behind the credential is valid. And this is usually done using DIDs, if you're familiar with those. Of course, notably, the holder has to have a wallet to store these credentials. But the main point of this system is that, the verifier and the issuer don't have to have a relationship, and that there doesn't have to be sort of any active communication between the verifier and the issuer. So one question about this is, how can we scale wallets, right? We don't want holders, which are, typically users in these systems, to have to, store a ton of information or keep track of every, issuers and verifiers, unique systems. So the idea is to have some kind of governance framework, and that's sort of where we see things, going. And, you can sort of picture this as, the authority is MasterCard, the issuer is a bank, and the card holder is the holder, the verifier is the merchant. And this is how like a payment using identity would work, right? So here's sort of an example of a full stack spectrum of identity. And this is from the Trust Over IP Foundation, if you all are familiar with that. which is another Linux Foundation project. And if you're interested, I'd highly encourage you to check it out. But essentially, there are 4 layers, right? There's a base sort of utility layer, and this is like your DIDs. There's a communication layer, which often involves the wallets. There's sort of what we call trust task protocols, which is sort of what the protocols to prove identity actually do and how they function. And then there are applications on top. And it's important that you have frameworks around each of these, because otherwise scalability doesn't happen. So interestingly, wallets are core to one of these layers, right? Layer 1 might be standardization, layer 3 and layer 4 are applications, but layer 2 is this wallet layer, and that's what we're concerned about. It's worth noting that digital wallets are everywhere. So according to this study, most people in the world will have a digital wallet, in just a few years. And today, when you say digital wallet, you pretty much think of one of these two, right? You have either Apple Wallet or Google Wallet. And many people aren't really happy with this duopoly. They'd like to have other wallets that they or their customers can use. And this is something that the Linux Foundation, with a global open source community, can solve. So recently, the LF has announced the intent to form the Open Wallet Foundation to develop interoperable digital wallets. So what's the purpose? The purpose of the Open Wallet Foundation is to support various open source data or other projects relating to the development of interoperable digital wallets. And if this sounds kind of broad, we'll explain it in more detail a little bit later, exactly why this mission is so broad. So today, people don't want a digital wallet that only contains one thing, right? If you have a standard wallet, here's my old beat up stainless steel wallet, I have a bunch of stuff in it. I have a bunch of cards, I have some cash, I have a food truck reward card, but the point is that lots of different stuff is in my wallet. And today we also want multi-purpose digital wallets. This is a big need from the market. So, the Open Wallet Foundation wants to develop, an open source engine. So this is a key, it's not a single wallet, it's an engine to enable secure and interoperable multi-purpose wallets. And we also want to set best practices for digital wallet technology for anyone who wants to build these wallets. What does this look like? Well, the OWF is recently started, and it is a big open source community. So the idea is everyone works in the open and brings together their different skill sets to build these multi-purpose wallets. We've had a ton of interest in the Open Wallet Foundation. There have been over 300 companies and nonprofits and other organizations that have expressed interest in joining and working with the foundation to sort of set up the background of the project and what it looks like. So how did we start? Well, we started by sort of, documenting, use cases, what a wallet architecture might look like. And this is sort of the very, very beginning of, what Open Wallet people wanted. And so this architecture diagram is already long out of date. But if you're interested in seeing what people are currently doing, there's a link there to the GitHub where a lot of this stuff is located. And, well, it's an open source project, so you're welcome to join the meetings, communication lists, anything like that. One of the core points of the Open Wallet Foundation is interoperability. It's not going to be useful if, everyone sort of contributes a bunch of different things that don't work together, and we end up with, dozens of different wallets that don't work together. But interoperability just doesn't apply to technical things, right? In fact, we say that the level required for open wallet foundation-based wallets in terms of interoperability to be accepted by governments and regulatory regimes, and that's certainly the goal, will require the core to solve for interop at 4 layers, not just technical. So the legal layer, right? We have to make sure that everything we do is in legal compliance. There has to be alignment of business processes and procedures. There has to be, essentially semantic understanding. So passing data back and forth and understanding what it means. And finally, the protocol layer, which is what most people think of when they think of interoperability. And this leads to a strong need and a desire for modularity. So this is just my interpretation of what a modular open wallet foundation might look like with different modules. This is not official, and discussions like this are ongoing. So if you're interested in this sort of thing, please feel free to join. And community's open. Everyone is more than welcome to join. But as you can see, we have cryptographic protocols, we have communication protocols, we have storage protocols. And then, we have actual wallet tokens and protocols, built on top of that. And then a policy manager, and then some things that are out of scope. So the goal of the Open Wallet Foundation is to build a wallet engine, remember. So things like a UI and sort of the last 20% of the project is most likely out of scope. So when talking to our members or potential members at this point, because the project has not officially been completed in terms of its launch, members have expressed an interest in contributing resources for a number of different building blocks. So payments, so companies like Visa and MasterCard are obviously interested in an open wallet for payments. ISO MDL is a big topic if you're familiar with this. Verifiable credentials and anonymous credentials, which are on the cutting edge of digital identity and decentralized identity, like Heather talked about. Travel credentials, and even a lot more things like car keys and digital car keys, for instance. So what does the foundation look like? Well, the foundation is hosted by Linux Foundation Europe, which is a subsidiary of the Linux Foundation, and joining it is equivalent to the Linux Foundation. The foundation has a number of different governing entities, a governing board, a governing advisory council, and a technical advisory council. And it's important to note that the technical advisory council is typically, in the long term of the project, it's made up of maintainers and others that are large contributors to the project, and then a lot of different individual projects. So, as you can sort of see, the foundation is actually what's called an umbrella project. And an umbrella project is an open source project that hosts, similar projects, components, and modules under its umbrella. Interoperability is usually desired. And here, you can see sort of, this is an old graphic for the Hyperledger Foundation, which is what I officially work for, before there were too many projects to put in an umbrella graphic. It was also an umbrella project. So one important thing to note, and if you're sort of familiar with open source, you've seen this before, but Linux Foundation umbrella projects, by definition, are collaborations, among multiple projects. And typically projects have a life cycle. And this life cycle is used to help people determine, the readiness and the production readiness of code, and sort of whether the community is able to support, extremely secure software. Typically, projects are proposed to the technical advisory committee, which can approve a project for incubation. Typically, projects in incubation are, starting off, they're getting there, but they have what it takes to succeed in the long run. Once projects reach a certain level of maturity, they're usually referred to as graduated. And then there are a number of stages for winding down projects. If a project has sort of lost its community or become obsolete, we don't want to leave it up there. We want to let people know that they should consider migrating on. So who's involved? So if any of you are familiar with the Linux Foundation, projects are funded by members, and the Open Wallet Foundation is no exception. And why do people join as members? Well, they're organizations that support the community, typically because they use the open source code base in their business, and they want to make sure that it's well supported. I can't really say much about the potential members at this point because the project hasn't officially launched and no one has joined. However, I will say if you look at the email list or you join some of the meetings, you can quickly deduce who is very likely to be members. However, it's worth emphasizing that anyone can contribute code or participate in the technical processes, including being promoted to technical leadership positions. So you don't have to work for a member company to contribute or to participate in anything. It's also important, and we wanted to bring this up, that there's going to be a large government and nonprofit role in the Open Wallet Foundation. In particular, the government of British Columbia, so where you all are, is expected to be an associate member of the project. And if you are a nonprofit or a government agency, we have an associate membership, and we anticipate working with our associate members on many topics related to, government applications and standards and so forth. So, I'd like to mostly conclude by saying that, anyone can get involved. It's really easy. Please feel free to join. We have a Discord. If you're interested in a technical and individual level, please follow the first link or join the Discord. And if you're interested, at a more general or a business level, we have a formation group. We haven't officially formed the project, so there's still time to join if you're interested. And yeah, that's about it. I wanted to leave plenty of time for questions. So if you're interested, please follow that link or reach out, and I'm happy to answer any questions you may have.
Thank you very much. It's time for questions. We have over 10 minutes. You may have that many questions. Is there any question? Question from the online participants.
Sure. I can't chat right now.
Okay, not Sakimura.
Hi, Hart.
Hey.
I know the answer. Hey, I know the answer, but for the benefit of the people who's hearing this for the first time. So if you find gaps in the standards and specifications, what are you going to do as the Open Wallet Foundation?
That's a great question. So we actually expect the Open Wallet Foundation to have, a substantial impact on standards and standardization bodies. The Open Wallet Foundation itself is probably not going to be a place for formal standards. Those will probably be pushed to things like the IETF and the W3C and the traditional standards bodies. But we do expect to, we expect to find gaps, and we expect that our members and contributors to help with standardization efforts around those gaps.
Thanks a lot.
Thank you. That was a good question.
Okay, other questions? Okay, I have one question to ask you. Okay, so the BGIN is the place for the discussion by multiple stakeholders, including government or central banks as other governmental public sectors. And during your presentation, you are talking about that one of the purpose of the Open World Foundation is that specification will be certified or recognized by government or regulators. And could you let me know that? So currently, so you have what kind of collaboration or relationship with regulators, including financial regulators or central bank? For example, that I'm thinking to create some software for the wallet for CBDC. You need to have a collaboration with central bank guys. But so what kind of collaboration are you thinking or you already have?
Great question. So are you familiar with the IDAS project, the European?
Yep.
Yeah, so there's a lot of communication between some of our potential members in Europe and the various European regulatory agencies. This is in fact why the project was officially or will be officially launched from the Linux Foundation Europe, is to make it, more, I guess, to make it easier to follow a lot of these EU regulations. As far as the US goes, I don't know if there's been any communication or not between any of the US agencies that are responsible for, for some of the recent CBDC stuff, like the New York Fed or the Boston Fed. The regulation and talking with regulators are, it's absolutely essential.
Thank you very much.
Yeah, hi, Hart. One question for you, actually, following up from that. This may be too early, actually, to answer, right? And it's very early stages, but I'm trying to understand one part of the vision here, right? To the extent there is a vision. So I work at a central bank, right? And when we think about CBDC, or really think about, a whole bunch of things that could appear on a wallet, there is this problem that if you're completely bound to Apple and Google right now, because frankly, anything else you do, if it isn't as quick as getting to it, right, or on those wallets, you're kind of dead in the water, right? I think that's kind of my thinking anyway. So what's the vision here? Is it to take some of the sentiment that you mentioned the European Union has, where that space has to be opened up and de-siloed somehow, so that it's highly portable, works across many platforms, so that we break that, we kind of break that stranglehold, if I can put it directly?
Yeah, so we have a lot of different people that want to join for a lot of different reasons. But certainly some of our potential members would strongly share that sentiment. The vision is not just really a single wallet. The vision is a wallet engine, right? So the idea is there will be components that you can sort of put together in various different ways, or you can mix and match what you use to build a wallet that's sort of specific for your needs. But we do anticipate, people wanting to build and put together general purpose wallets that that meet a lot of different needs. It's sort of Mike Dolan, who's the head of project formation at the Linux Foundation, says he has 8 different wallets on his phone, and he'd like to only use one. I hope that answered your question. But in some ways, the vision is flexible because we have a lot of different potential member companies and contributors who want to get different things out of the open source code base, if that makes sense. And then that's true for most open source projects.
Yeah, for sure. That's helpful. Thank you.
Okay, next question.
Thank you so much for your presentation. So I just wonder, in terms of the cryptography kind of authority or the standards that you're trying to set for your digital wallets, what are some of the kinds of cryptography authorities or currently that you're currently using, or because we're currently establishing more kind of advanced cryptographies at the moment, including post-quantum cryptography, as well as a few others that are at the forefront of the US National Institute of Science and Technology standardizations. So we wonder if there's any kind of potential for collaboration, or what are your current standards at the moment? And yeah.
Yeah, so beyond sort of, very basic cryptography, so, standard key exchange signatures and so forth, I believe we will also be using threshold signatures for things like, for various authentication scenarios. I can't say for certain because I don't know what will get contributed or what will get built, but I expect something like that will be present. Two of the main tracks that people want to work with are W3C verifiable credentials and anonymous credentials. Those are very, very heavy in terms of what they do cryptographically. They're essentially, and very informally, they're sort of lightweight zero knowledge proofs. If you're interested in, cryptographic protocols and advancing, cryptography, those are great things to look at. As far as post-quantum crypto goes, I suspect that our members and contributors will want to support standard post-quantum cryptography stuff like key exchange and signatures, which is what NIST is standardizing currently, as you alluded to. As far as zero knowledge proofs and other stuff, the post-quantum, efficient post-quantum, ZKPs are sort of early. I mean, I guess you can use Starks and other things, but the current verifiable credential and anonymous credential, schemes are very, very much based. So there will probably have to be some advancements to find suitable post-quantum replacements for those. Did that answer your question?
Yeah, for sure. That's really good. Do you have, if you have your point of contact, like your email, then we can maybe send you some of the one pager that we've already developed with our developers in terms of PQC and stuff for you to review. Yeah.
Yeah, absolutely. Feel free to reach out. I can, give my email is just hmontgomery@linuxfoundation.org, or it should be publicly available. So please feel free to reach out.
Okay, other question? Yeah, I have a similar question, because that is, that the previous talk is on the zero knowledge Soban token.
Mhm.
Soban token community is developing very new protocols, and from now, I think, and the wallet software provided by Open Wallet Foundation. Soban token community members expect Open Wallet Foundation software have the capability to execute zero knowledge proof protocol designed by the Soban token community, but so it's not easy to have the synchronization of the development of the protocol by Soban token community and the development in the Open Wallet Foundation. I think that this is the reason why that collaboration with different types of open source community is essential, but it's not easy, I think, to organize. But what do you think about that?
Oh, totally. I mean, collaboration is absolutely important. And at the Linux Foundation, we try to collaborate with everyone we can. As long as open source code is licensed appropriately, then we're happy to take in code from other sources. The Open Wallet Foundation is already probably going to take in a bunch of code, or rather rely on a bunch of code from Hyperledger, certainly for the anonymous credentials portion of the project. We expect collaboration, and if people who are working on the project want to use something like these soulbound tokens, that would be great. So yeah, we hope people want to collaborate.
Thank you very much. Any other question? My last question is on the security. So my background is cryptography and its application and its implementation. And so it's not easy to prove that software, the hardware implementation are secure, especially for the government use case. And how do you prove that your security of your code? And
yeah, security is a big thing, and we've had a lot of discussions on that. In our experience, the best you can do is follow best practices, and do the best you can. As you're obviously aware, even the most critical software on the internet, like TLS, sometimes has security vulnerabilities. I'm sure everyone remembers the Heartbleed attack. But our goal is to have follow best practices, have everything reviewed by the appropriate people, use well-reviewed, well-studied cryptographic schemes. So obviously don't roll your own crypto. Have people who understand all the parts of the stack review the code. So have people who understand cryptography from a mathematical perspective, have people who are really good at implementing review, do a whole review stack, and then do things like security audits, bug bounty programs. I mean, we could talk an hour and a half easily on the best practices for securing open source code. And there's a whole huge effort at the Linux Foundation called the Open SSF, which is dedicated to raising the security levels and best practices of open source code. And they have a whole ton of information and resources on this. And I'd encourage anyone who's interested in security to check it out.
Thank you. Good to hear that. Have you considered consider that, for example, that common CMVP is common cryptographic module validation program?
Have we considered what?
So CMVP, so cryptographic module validation program.
Yeah, so most of the cryptography is outside. Very little, for some of the credentials, they obviously need cryptography, but most of it is, mostly, again, we don't want to roll our own crypto. But yeah, we have a number of different validation things in the Linux Foundation and a bunch of different strategies. And I don't know exactly what the OWF will choose in terms of exact strategies.